Okay, the last of the first lesson on Taylor is a piece of an old free response. It's not the whole thing, but it is parts A and B. It says let h be a function having derivatives of all orders for x is greater than 0. Selected values of h and its first four derivatives are indicated in the table above. The function h and these four derivatives are increasing on the interval 1 to 3. It says write the first degree Taylor polynomial for h about x equals 2. So I'm going to be looking at x equals 2. So I really don't care too very much about 1 and 3, for this problem at least. And use it to approximate h of 1.9. Is this approximation greater than or less than h of 1.9? Explain. So we want the first degree Taylor polynomial. Well, the first degree Taylor polynomial is just the equation of the tangent line. When they say degree, they're talking about the exponent. So it's just h of 2 plus h prime of 2 times x minus 2 over 1 factorial prime. These, if you notice, the prime, the exponent, and the factorial always match. When they say first degree, they mean this right here. If it's second degree, they want you to go out to the squared, third degree to the cubed, and so on and so forth. So I'm just going to fill these in. H of 2, 80, plus h prime of 2, h prime 2, 128, times x minus 2. Okay? And that is my first degree Taylor polynomial, so that's T1 of x, or you could say P1 of x, depending on how you wanted to do it. So that's the first piece. Now it says use it to approximate h of 1.9. Well, just like you would use the tangent line to approximate h of 1.9, you just fill in a 1.9 where the x is. I'm just going to go ahead and tell you that you get 67.2 when you work that out. Is this approximation greater than or less than h of 1.9? Now here is where it gets interesting. At 2, this thing has a positive second derivative. If it has a positive second derivative, what does that tell you about your graph? It's like Dora the Explorer. What does that tell you about your graph? It's concave up. Okay? Your graph is concave up on that particular at 2. So if it's concave up at 2, and you have your tangent line here, and you're looking at 1.9, okay, so this is 2, 1.9, is that going to be an under approximation or an over approximation? Well, because your tangent line is below your curve, it's going to be an under approximation, so it's going to be less than the true value at 1.9. Okay, and then B, write the third degree Taylor polynomial for h about x equals 2 and use it to approximate h of 1.9. I'm going to have to erase all this because I'm not going to have, it's like I can't scroll up and down and have enough room. So we're just going to go ahead and do B right here. It says write the third degree Taylor, so I want h of 2 plus h prime of 2 times x minus 2 over 1 factorial plus h prime double prime of 2 times x minus 2 squared over 2 factorial plus h triple prime of 2 times x minus 2 cubed over 3 factorial. Okay, so now I'm just going to fill my values in. I'm struggling. How about if I just make this smaller? It's like I can't see everything at one time. See if I can move that up. Yay. Alright, so h of 2, again, I'm only looking here. H of 2 is 80, plus h prime of 2 is 128, times x minus 2 over 1 factorial. I'm just going to let that go. H double prime of 2 is 488 over 3. I'm just going to go ahead and put my 3 down here with my 2 factorial, if that's okay. X minus 2 squared. Plus the next one is 448 over 3 times 3 factorial times x minus 2 cubed. And then I could leave it like that. I could clean it up if I want to. That is a numerical answer. It's perfectly fine. I can go ahead and go one more step just to be thorough. 80 plus 128 times x minus 2 plus 488 over 6. I don't know what that is. I'm going to make it 488 over 6. X minus 2 squared over 6. I do not remember if this is with calculator or without. I hate to say and be wrong, so I'm just not going to say. 448 over, that's 18, x minus 2 cubed. Alright, and that's kind of what a Taylor free response looks like. There's another piece that's on this one, I believe, was the Lagrange error bound, which we are going to talk about tomorrow. Yay! Alright, see you guys tomorrow.